Today we're going to look at simplifying complex fractions, and our objective is to be able to simplify completely any complex fraction given to you. So what is a complex fraction? Sometimes it's referred to as stacked fractions, and to kind of think about fractions over fractions, or having a rational expression in the numerator and the denominator. So we're going to talk about two methods used to simplify complex fractions. Method one I'm going to call is when we treat the numerator and denominator as two separate problems, and then we eventually multiply by the reciprocal of the denominator. Method 2, we're going to find the LCD of all the denominators, then multiply each individual fraction by the LCD, which is basically multiplying the numerator and the denominator by the same value, which is like multiplying by 1. So I'm going to go through 3 examples with you. Each example I'm going to do in method 1 and then also as method 2. I find method 2 a little bit quicker, however it could be a little bit more complicated if you don't understand what's going on. So I'm going to show you both methods, so at the end you can choose which method is the easiest for you. So example number 1, we're going to use method 1. Method 1 looks at the numerator and the denominator as two separate problems. So if I just look at the numerator, I have 15 over 1 minus 2 over x. My LCD, okay, I have a 1, so I need a 1, and an x, so a 1x or just x. Okay, so that's going to be my common denominator is going to be an x. So I have a 15, but my denominator was a 1, so I'm missing an x. Okay, whenever I see my sign, I like to change it to a plus and negative. So I have a minus 2, and I'm not missing anything from my denominator for my LCD, so I just get 15x minus 2. I can't do any more simplifying, so that's my numerator. But I'm going to do the same thing in the denominator. So this is x over 5 plus 4 over 1. So my LCD would just be 5 times 1, which is 5. So I'm going to write my common denominator. I have an x in the numerator, but I already have a denominator of 5, so I don't need to multiply anything. Plus 4, but I have a 1, but I need to multiply it by a factor of 5. So now I have a numerator, which is just 15x minus 2 over x. And in my denominator, I'm going to clean up a little bit, is just x plus 20 divided by 5. Once I get down to a single fraction over a single fraction, now, okay, what I'm going to do is my last step. Well, we don't like to divide by a fraction, so instead we like to multiply by the numerator. So I'm going to take my top fraction, and instead of dividing by this, I'm going to now multiply by the reciprocal. And the reciprocal would be 5 in the numerator, x plus 20 in the denominator. So you might think, well, what am I going to do for this problem? Well, what you want to do is this is what we did in section 8.4. Now we have a multiplication problem. We don't have an addition and subtraction. So we want to look at the numerator and denominator separately and think, can I factor anymore? Well, 15x minus 2, I can't factor at all. So this is, I'm going to leave it like this. X we can't factor, so I'm going to leave that just like that. 5 I can't factor, and x plus 20 I can't factor. So if I look, none of these factors are identical. I can't reduce any of them. So my final answer, we usually put the number first, so I have a 5, okay, times a 15x minus 2 over an x times x plus 20. Now we usually always leave our denominator factored. Sometimes we can distribute our numerator, but right now, since it's already factored, we should just leave it like that, and that would be my final answer. So how would we do this in the second method? Well, in the second method, what I want to do is make each of these terms as a fraction, and I want to find my least common denominator for all of my denominators. I have a 1, an x, a 5, and a 1. Well, if I have a 1 and a 1, an x, and a 5, my common denominator would be a 5x. Okay, I can make each of these denominators 5x by multiplying by something. So now what I'm going to do is multiply each, basically I'm going to multiply the top and the bottom by 5x. Well, if you multiply by 5x, that's the same thing as multiplying each fraction by 5x. Okay, so let's think about a better way to look at that. So instead I'm just going to do this. 15 okay, times 5x minus 2 over x times 5x, okay, all over, and I'm just going to do the same thing with the denominator. I have an x over 5. I'm going to multiply that by 5x, and then I have a plus 4, and I'm going to multiply that by 5x. So what I'm going to do is find the LCD looking at all the denominators and then multiply each fraction by that. The reason we do that is because by multiplying by the LCD, I'm going to get my numerators, my new numerator, to reduce with my denominator if it has it. So if I look here, 15 times 5x is going to give me 75x. Okay. If I look here, this x can reduce with this x, so I'm left with minus 10. So if you look, I don't get any fractions in the numerator. I just get one single numerator, a polynomial. In the denominator, 5 reduces with 5, so I'm left with x squared, and then plus 20x. Okay, so this doesn't look exactly like what we had in the last problem, but we can still simplify. So if I simplify this, in the numerator I could factor out a 5, which will leave me with 15x minus 2. In the denominator I could factor out an x, which would leave me with x plus 20. That's the exact same answer we got in the last problem, but some students find this will be a little bit easier by multiplying the LCD. Both get you the same answer. Let's look at our second example. I'm going to do method 1 first by looking at the numerator and denominator separately. So the first thing I want to do is factor, if I can, my numerator. Well, 2x minus 5 doesn't factor, so I'm going to leave it like 2x minus 5. Again, I don't like a minus sign, so I'm going to make it plus a negative 7 over, but I can factor out a 4 in the denominator, which leaves me with 2x minus 5. Now that I have this, I can find my LCD. My LCD is now going to be a 4 times a 2x minus 5. Okay, so what that's going to do, I'm going to be able to write my common denominator, and I would think, what am I missing? Okay, my first numerator is a 1, but what am I missing from the LCD? I'm missing a factor of 4, so I'm going to multiply by 4. Okay, my second fraction, I have a minus 7, but I'm not missing anything from my LCD, so I could just leave it like that. Okay. My denominator, the nice thing about my denominator, it's already one fraction. So I don't have to find a least common denominator because this is just x over 2x minus 5. So again, I have a fraction divided by a fraction. So instead of doing that, okay, I'm going to clean up top. 4 minus 7 is a negative 3 over 4 times 2x minus 5. But I don't want to divide by this. Instead, again, remember, I'm going to multiply by its reciprocal, which would be 2x minus 5 in the numerator, x in the denominator. So again, remember, this is our 8.4 section. This is just multiplying fractions. So what I want to do is factor each part. This I can't factor. 4 times 2x minus 5 is already factored. 2x minus 5 I can't factor. X is just a single term, so I can't factor it. So now I want to think, is there anything I can simplify? Well, this 2x minus 5 can simplify with that 2x minus 5. So I get a final answer of negative 3 in my numerator and a 4x in the denominator, and I can't simplify anymore. So let's look at the same example, but using method number 2. Remember, method number 2, okay, looks at all the denominators, and we have a 2x minus 5, a 2x minus 5, and again this factors to 4 times 2x minus 5. So if I look at all my denominators, my LCD for all of them, well, if I look at this denominator, I need a 2x minus 5. If I look at this one, I need a 2x minus 5, but I also need a 4. And if I look at the last one, I need a 2x minus 5, which I already have written down. So what's going to happen here? I'm going to take each of these fractions, I'm just going to write it out a little bit more spread out so you can see. And I'm going to multiply each one by my common denominator of 4 times 2x minus 5. Again, I don't like that minus 7, so I'm going to make it plus negative 7 over 4 times 2x minus 5. But remember, I'm going to multiply this by a 4 times 2x minus 5. Then if I go to the denominator, I have an x over 2x minus 5, but I have to multiply by my common denominator of 4 times 2x minus 5. Now if you notice, my LCD contains parts, if not the whole thing, of the denominators. And the reason we do this is because we're going to be able to reduce 2x minus 5, 2x minus 5. So I'm just left with a 4. If I look at the next one, 4 and 4, 2x minus 5, 2x minus 5. So I'm just left with a minus 7. Okay, over. If I look here, I have a 2x minus 5, a 2x minus 5. So I'm left with x times 4, which is 4x. And if I simplify this, I get negative 3 over 4x, which is the exact same thing we found in the last problem. And if you can notice, we get to our final answer a little bit quicker here. The problem looks a little bit bigger because we have to rewrite the LCD, but some students like this better than number 1. And again, on a test, it doesn't matter which method you do. Let's look at one last example. Again, with method 1, I'm going to look at the numerator and denominator as two separate problems. So this one, again, I'm going to save a little bit of time, so hopefully you can tell the factoring. X squared minus 4 is x plus 2 and x minus 2. So my LCD is going to be an x minus 2 and an x plus 2. Okay, so I like to write the numerator and then think, what am I missing from my LCD? Well, I have an x minus 2, but I need an x plus 2. Again, I don't like a minus sign, so I make it a plus and negative. I have a negative 6. And what am I missing? Well, I'm not missing anything. So that is my new numerator. Okay, and I'm going to clean it up a little bit. Okay, if I distribute, I get a 3x plus 6 minus 6. And in my denominator, just keep the same. So that's it written as one fraction. I'll clean this up later. Okay, let's look at our denominator. I have an x plus 2 and an x minus 2. So my LCD is just going to be an x minus 2 and an x plus 2. And again, I'll write the plus first and then the minus. Again, it doesn't matter what order. So my first fraction, I have a 3 in the numerator, but for my LCD, I'm missing an x minus 2. Then I have a plus 1. But in this denominator, I'm missing an x plus 2. Again, now I'm just going to combine this, distribute. I'm going to get a 3x minus 6 plus x plus 2. And this is over x minus 2, x plus 2. Or in this case, x plus 2, x minus 2. So again, I have a fraction divided by a fraction. So what I'm going to do is simplify this fraction, which just becomes a 3x divided by x minus 2, x plus 2. But again, I don't like to divide by a fraction, so I'm going to multiply by the reciprocal. My denominator now becomes my numerator, so I have an x plus 2 and an x minus 2. And my numerator becomes the denominator. Well, if I combine like terms, I have a total of 4x minus 4. Okay, so let's see, can I simplify anything right now? Why don't x minus 2, x minus 2, x plus 2, x plus 2. But before I go on, hopefully you realize that this factors, I can pull out a 4, a GCF, and I get x minus 1. So let's see. Okay, this doesn't exist anymore, so I can just cross that off because I've already rewritten it. 3 and a 4 don't reduce. X and an x minus 1 aren't the same. So even though I factor that, nothing more simplifies, so I'm left with a 3x in the numerator, a 4, x minus 1 in the denominator, and that's my final answer. So let's look at this one in method 2. Again, I'm going to do the same thing. I would have factored this to x plus 2, x minus 2. Every other denominator cannot be factored anymore. So I want to find my LCD. So if I look here, I need an x minus 2. If I look at this one, I have an x minus 2 already, but I'm missing an x plus 2. This denominator needs an x plus 2, which I have written. This one needs an x minus 2, which I have already written. So that's my LCD. So what I'm going to do Some students might be able to skip some of these steps and be able to do a little bit of work in your head, but just remember, on a quiz or a test, it's always nice to show your work in case you make a mistake, because I can't see what you're doing in your head, so showing your work is always best. So I'm going to rewrite what I already have, and then just remember, multiply the numerator by the LCD. Again, I don't like that minus, so I'm going to make it plus 6. And I have an x plus 2, x minus 2. So I'm going to multiply. I have my LCD. And then do the same thing in the denominator. And again, some of you can kind of see where this is going, but at least for your notes, it's nice to have more steps in case you forget, you know, a week, 2 weeks down the road, you know exactly what you did. And then my last fraction is 1 over x minus 2. And I'm going to multiply that by the LCD. And again, the reason it's okay for me to do this is because this is the same as multiplying the numerator and denominator by x minus 2, x plus 2, which x minus 2 times x plus 2 divided by itself is 1, and it doesn't change it. And if I have anything times numerator, I would have been able to distribute, which gets me this. So now I'm going to go through, and I'm going to see x minus 2 and x minus 2 reduce. So I'm left with a 3 times an x plus 2. In my second fraction, that all reduces, so I'm just left with a plus 6 divided by. And in my denominator, x plus 2 and an x plus 2, so I'm left with a 3 times x minus 2. And in my last fraction, x minus 2 and x minus 2, so I'm just left with a plus 1, x plus 2. So I'm going to do a little bit of distributing here. Okay. So I get a 3x plus 6 plus 6. And in the denominator, I'm sorry, this should have been a plus, a negative 6 from the beginning. I said make it a plus negative 6, and I forgot the negative 6, so this should actually be plus negative 6. Okay, and in my denominator, I'm left with 3x minus 6 plus x plus 2. So if I simplify here for my last step, I'm just left with a 3x in the numerator, a 4x minus 4 in the denominator, which is the same as 3x, divided by 4x minus 1 if I factor it out. Okay, which is the exact same answer I got using method number 1. I hope you feel a little bit better about simplifying complex fractions, whether you use method 1 or method 2, and you're able to simplify them completely using our LCD and factoring.